have the rules of divisibility, if you will raise your hand, Mr. Simmons, you might put a hole punch to that before you hand those out. You already did? Okay. Mr. Simmons is going to give you your rules of divisibility. Okay? Get out your homework folder and put it in it. Fasten it into that homework folder. Do you have another question, Callie? Did everybody pass them through?
Yeah.
So, do you guys still need some more?
No.
Okay, now then, I really want to start teaching, and the quicker I start, the more time you have to work. Does everybody have the rules of divisibility? It's now in your folder, and you have that folder open and in front of you, because we're going to use the rules of divisibility. So don't just put it away. Everybody should have that. Does everybody have 1.4 Prime Factorization A?
Yes.
Good. I want that one out. You want one of these two?
Yeah.
Okay. Now, what did I say our goal is going to be in this section? What's the goal? What are we going to have to be able to do by the time we get done with section 1.4? What are we going to have to be able to do, Aubrey? Write the prime factorizations of a number. I can't do that if I don't know my rules of divisibility. They make it super easy, okay? That's why I gave that to you. Now, if I look at number 1 up here, the number 700, it says here, by instruction, use divisibility rules to determine whether the number is divisible by 2, 3, 5, 6, 9, and 10. Use a calculator to check your answers. Does she not have the right paper? Okay? With that being said, looking at the rules of divisibilities, you're just going to ask yourself on every number. 780, is it divisible by 2? Thumbs up, yes. Thumbs down, no. Is it divisible by 2? Need to have a thumbs up. Somebody tell me how they know that it's divisible by 2. Isaiah.
Because 2 times 4 can go into 8.
That's true, but that's not how I know it's divisible by 2. How do I know that it's divisible by 2? Miss James, what is your first name?
Brianna.
Brianna, okay.
Because it ends in an even number.
It ends in an even number, okay? So that tells me it's divisible by 2. That's the rule of divisibility.
14.
Is it divisible by 3? Is 780 divisible by 3? Thumbs up, yes. Thumbs down, no. Show me. You need to have your thumbs up. It is divisible by 3. Now somebody tell me why. Kagan?
7 plus 8 equals 15, and 3 times 5 equals 15.
7 plus 8 is 15, or the sum of its digits is divisible by 3. Is 15 a divisible number by 3? Sure is. And that is the rule for the divisibility of 3. Okay? Is this number divisible by 5? Thumbs up, yes. Thumbs down, no. Showdown. It is. Why? How do you know it, Faith?
Because the last number is 0.
Okay. And in order to be divisible by 5, it has to end in a 0 or a 5. Good. Is it divisible by 6? Thumbs up, yes. Thumbs down, no. And the rules are there. So look at the rules of divisibility, because if you do, you already know this answer.
Yeah.
Showdown. Thumbs up, yes. Yes, it is. How do you know that? How do you know that? Melissa, how do you know?
Because if it's divisible by 2 and 3, then it's divisible by 6.
If I can divide it by the numbers 2 and 3, then yes, it's divisible by 6. Okay? What about 9? Is it divisible by 9? Thumbs up, yes. Thumbs down, no. Showdown. Good, it is not divisible by 9. Because what's the rule for divisibility of 9? What is that rule, Brian?
Sum of all the digits is divisible by 9.
The sum of all the digits has to be divisible by 9. We said the sum of the digits 780 is 15, right? Is 15 divisible by 9? No. So neither is that number. What about, is it divisible by 10? Thumbs up, yes. Thumbs down, no. Connor? Yes, I agree. Why? How do you know it? Just by looking at it.
Because the number
It ends in a 0. Do you see how I identified this? Now I could get a calculator out and check it, but I'm not going to right now. Okay? I could, but I don't want to. I want to keep going. Is that all right with you?
Yeah.
Okay.
Is 4 not on here?
4 is not one that it wants us to look at right now. Okay? It wants a specific. 2, 3, 5, 6, 9, and 10. Those are my specific ones right now. Okay? Look at number 2. You make the determination and write down on your paper all that 3,675 are divisible by. You just have to write the ones that it is divisible by on your paper. And you just go through what I just did. Kelly, did you get it done? You got it all done? That's okay. Go back up and do number. It's okay. You don't have to worry about that. So would it be? And what's the rule for? What's the rule? Okay. So does that affect this one? What's the rule? Okay. Good. Good. Mhm. You might take a look at these ones. You might add the digits again. Isaiah, check this rule. Yes. I'm missing one. Go back and look at that rule. That work? There is another one now. Look at the rule. Okay, ladies and gentlemen, the rules of divisibility. Is 3,675 divisible by 2?
No.
No. Is it divisible by 3?
Yes.
Yes, it is, because when you add the digits up, you should have gotten 21. And 21 is divisible by 3. Okay? Is it divisible by 5?
Yes.
Yes, it is, because it ends in a 5 or a 0. Is it divisible by 6?
No.
No, it's not divisible by 2. It can't be divided by 6. Is it divisible by 9?
No.
No, the sum of the digits was 21. it divisible by 10?
No.
No, it doesn't end in a zero. Okay? So let's just go really quick here. Is number 3, is it divisible by 2? Yes. Is it divisible by 3? Let's see, 3 plus 3 is 6 plus 3 more is 9. Is that divisible by 3? Yes. Is it divisible by 5? Nope. Is it divisible by 6? Yes? Because it's divisible by 2 and 3. Is it divisible by 9? Yes. We said the digits added up to 9. Is 9 divided by 9 a real answer? Sure. So yes, 9, and not 10. 10, no. So if I want, but the only way that I know is if I check every single one of them. And you have the rules here. And I want you to get these basic rules in your brain. Because these will serve you anytime you want. Get these into the memory. Okay? We know how to find rules of divisible, whether it's divisible. Do you agree with that now? Can you use these rules and be successful? Yes? I think so too. I don't want to take more time up. Now let's look at this though. Oh, I think before I even go there, we're talking about writing things, numbers, as their prime factorization. Well, I'll go one further, and then we've got to do a definition. The brass section of a marching band has 30 members. The band director arranges that brass section in rows. Brass is your trumpet and tuba, and is the saxophone a brass? No, it's woodwind, isn't it? Trombone? Okay, good. Let's see. Each row has the same number of members. How many possible arrangements are there? Well, if I want to know that, and I know my number is 30, are my rules of divisibility going to help me figure that out? Sure. Is the number 30 divisible by 2?
Yes.
2 times what?
2 times 15.
That would be one arrangement. Do you agree? Is it divisible by 3?
Yes.
Sure it is. 3 times.
10.
Okay. Is it divisible by 5?
Yes.
5 times.
6. So obviously.
Is it divisible? Well, we know it's divisible by 6, but that arrangement is already there. Do you agree?
Yeah.
Well, no, it's not, because I could have 6 rows with 5 people, or 5 rows with 6 people. So that would be a different arrangement. Do you agree?
Yeah.
Okay. Is it divisible by 9?
No.
No. How about 10?
Yes.
Yes. Okay. And I could say then 15 times 2. Do we agree? So how many possible arrangements are there?
6.
There are 6. There are 6. Was that hard to do?
No.
No. Did rules of divisibility make that easier?
No.
And math is very organized. It's very methodical. It's step 1, step 2, step 3, step 4. I mean, it's so organized. And if you maintain that organization in your math, you'll find that you're going to kick its butt because it just makes it easy. Okay? All right. Now we're going to stop right there. We're going to put a page in. I want this one up here. Okay. Go to your definition pages. You should have a web page still for definitions. Yeah, remember at the back of your binder. Let me see. Excuse me, I know that, and you got to give me time, okay? You should have a page that looks like this. Do you have a blank one of them? Graphic organizer for spelling. I think there's enough there to get everybody one. You want to hand me some and I'll do one side and you do some on the other side. How's that? That works. Thank you, sir. Okay, everybody needs a new graphic organizer. What word do you think you're going to put in the center of it?
Divisibility.
Nope.
Prime number.
Prime factorization is what we're going to define. graders? 4?
Oh.
I got 3. Mr. Simmons, I bet we're gonna be short. You wanna take one of those and go make a bunch? Okay, I understand. 6th graders. Today, you're extremely needy in that I can't hardly say 2 words without you telling me what you need. Give me time. 20 is fine, but then make 100 of them. But 20 will get me going, okay? Okay, so Mr. Simmons is making some more of those. So I will have one for you. But in the meantime, because I don't want to waste a lot of time waiting, we're going to go ahead. This is kind of my mock, right? We said prime. Prime factorization, okay? Oh, that'll just be the start of it. We're going to start with that. We actually have 3 words we're going to do today. Prime factorization of is the number written as a product of its prime factors. The number written as a product of its factors. That's the definition. Those of you that didn't get the page will have it here in just a minute. Okay? Remember, I am videoing this, so it's also going to be out there on Google Classroom. Okay? You're also going to see it. We're going to talk about it being in, and if I use the term expanded form, primes only. Okay? For example, pick a number. Let's not go great big. Somebody give me a number. 40. Okay. Okay, now it says written as a product of its prime, the number written as a product of its factors, and we're talking primes only. That's the only thing that can be there. Well, what is a prime number, first of all? Somebody tell me, and we've done this, it's review, so what is a prime number? What's a prime number, David? One and itself, good. Is the number 2 prime, class?
Yes.
1 times 2 is 2, that's the only way you're going to get it, right? Is the number 3 prime?
Yes.
Is the number 4 prime? No, we call that composite, okay. So, 40, okay? Now, I need to know, what are the prime factors of 40? I can only use primes, so there's different ways that we could do it. Miss Faith.
2.
2 goes into 40, I agree. And it's 2 times what, though? 2 times 20. So 2 is a prime factor, But 20's not a prime one, is it? Okay? Anybody ever see something that looked like this? Called it a factor tree. You ever seen factor trees?
Yes.
We're going to be using factor trees. We can also just list all the factors of 40. But at this point, 2 times 20 is 40. Now this one is not prime. Do you agree? I'm going to circle a 2 because it is. What are my factors? I'm trying to think of prime factors. So do you agree, is the prime number 2 going to go into 20? Yes? 2 times what?
2 times 10.
Okay.
Same thing.
10's not prime, is it? It's composite. Is 2 going to go into 10?
Yes.
Yes.
5 times.
2 times.
5.
Now, is the number 5 prime?
Yes.
Do I have a grouping of all the prime numbers that will go into 40?
Yes.
Okay? My prime factorization is written as the product of its factors. The prime factorization for 40 is 2 times 2 times 2 times 5. That's the prime factorization, the way it's written. I could also write that this way. 2 to the 1, 2 cubed, 2 to the 3rd power, times 5. Okay? The prime factorization is nothing more than writing all of the prime factors as a product. Okay? That's my prime factorization right there. Or this, either way. Okay? Either way. Now, what if I wrote this? Is that a prime factorization? No. Why not? Why not? Raise your hand. Why is this not a prime factorization? Amelia?
20 is composite.
Because 20 is a composite. It's not a prime number. So this is a non-example. Okay? Is it bothering you? I'm sorry. Okay, did everybody get that graphic organizer now? Is everybody able to fill out this graphic organizer?
Hold on.
Okay, well, I'm not going anywhere yet. I'm letting you guys get it done. And I'm going to make a note right here because this is a really important one right here. This is a prime factor tree. Okay? The base of the tree was 40. Now the fruit that comes off of that tree is all prime numbers. See how they're circled? That's the fruit. Does that make sense, Brian?
Yeah.
Yeah. The fruit of this tree is all prime numbers. That's why I call it a prime factor tree. Some people do factor trees and they're not prime. But if I have to go to a prime factorization, isn't it smart just to always be thinking about what your prime numbers are?
Yeah.
To me, that's just smarter. Work smarter, not harder. Okay? Now, I could come over here. When you think of the number 40, what number did you think automatically would, before you did all this, or let's go with this one. Let's change this to the number 30. What factors go into 30?
6. 3,
I heard 6.
3, 5.
How about 5 and 6? There we go. Now that, they're just kind of pulling some out there. This one happens to be prime, doesn't it? But this one's not. So this could end up being a prime factor tree, couldn't it? Because I could circle this one and then take the branches there. And I could have my 3 times 2. Okay, I'm going to write it just the way you said that. And here's why. Now then, a prime factorization, another thing that is extremely important, they're written in order from least to greatest. That's a huge additional factor. Written least to greatest. Okay? That's that organization piece of it again. Okay? So if I now, and you can do it your way. I need you to not, whatever you're doing over there, okay? I'm not sure what your expressions are about there, Kagan. All right? I have, and you know what? If you're not making an expression towards anybody, that's fine, but hear me out, okay? I seen a young man this morning, dad's come to school, right? And I seen one of my old students come in. And I said, hey, and it was really cool seeing this student. I love it when students come in that have all grown, and I guess he was here because he had a kid, and that's kind of scary. He had a kid that was here. So he come, you know, dad's to school, right? All right. But this kid, I remember this kid in class, first 8th grade class I ever had. And this kid and his classmates communicated a lot across the room. There was a lot of what we called hand jive. They'd make signals to one another. Or they'd just give each other looks. And then when the teacher would turn around, they knew something was going on, but it was kind of hard to put their finger on it. Wasn't for sure exactly what was happening, but you knew something was up. And in math, when I see everybody giggling, I'm like, okay, what's up? Because most kids don't laugh during math. It's a dead giveaway, guys, okay? So sometimes when I turn around, if I see that it looks like you're making an expression towards somebody, I may check on it, okay? And if you weren't, that's fine, all right? But I wasn't sure, because I know sometimes I got a couple of my young guys that like to talk across the room, and they do it with their eyes. Nonverbal communication. Oh!
I wasn't even talking to him.
Yeah.
Oh, how do you know I'm talking about you?
Because you were looking at me.
Exactly.
Okay,
And also the closest ones.
okay.
I was
And this time, and I'm fine with it that you guys weren't.
I was looking at Tyler because they were talking and Tyler was like, and then I looked at her and she was like,
Okay, so I'm right. There was, okay, whoa, freeze. Mrs. Rakestraw was not wrong. There was nonverbal communication going on just then. Okay? And it might not have been the 2 gentlemen, but there was still nonverbal communication going on, and that's what I caught. Okay? So, yeah, I'm not crazy.
Oh, I thought you were crazy, lady.
Well, yeah, I am, but not that kind of crazy, okay? All right, back to math. Back to math. Do you see, though, where if I organize my prime factor tree from least to greatest, how much easier it is just to write it there than over here, I've got to remember to put it back in order, and I would write it like this. Okay? There I've already got it in order. Here, my factors are all there, but I have to make sure, remember to put them in order. So that's a habit that I got into. It's a good habit. Am I going to count it wrong, though, if you do a prime factor tree like this? No. But if you don't put this in order, yes, I would count it wrong. Okay? Because I want you to do it in the right way. Okay? All right, so prime factor tree. Let's go. We need another one. Good. We need another box. And the word that we need there is factor pair. It's 2 words technically. Factor pair okay? Oh, I better put that away. I'm gonna end up writing. How would we define factor pairs? How can we write a definition? Do you know what I'm talking about when I say factor pairs? Two factors that go together. I agree with that. Up here on the number 30, I'm going to just kind of write this over here. If I wanted to know the factor pairs of 30, could I have 3 times 10?
Yep.
Could I have 2 times 15?
Yes.
Could I have 5 times 6?
Yes.
Those are all factor pairs. It is a pair or two numbers when multiplied together equals a specific product. Okay? So that sounds a lot of technical words there, right? So I have two numbers multiplied together to get, we're going to say specific number, okay? Can I use the abbreviation hashtag?
Yep.
That honestly wasn't hashtag years ago. That's the symbol for number. Hashtag really means the word number. And if you just see it as hashtag, you may spell the word out. I know that that means number. Okay? Okay. And we could put, for examples, we could say 3 times 10 equals 30. 2 times 15 equals 30. And that looks like a 3 there because of the way I made my 5. Got it. And I could say 5 times 6 equals 30. Those are all, 3 and 10 are factor pairs, 2 and 15 are factor pairs, 5 and 6 are factor pairs, all for the specific number 30. Do you agree with that?
Yes.
Okay, it takes 2. And if we're talking, that takes 2 also. And so 2 will get the cube, not just 1. Okay? That's called a talking pair. Okay? All right. What if I said, is this, if we're dealing with the number 30, are 3, 2, and 5 factor pairs? No, they're not factor pairs. They are just factors. They're all factors, but they're not factor pairs. Oh yeah, I could throw 1 in there too. And I could throw, if I'm listing here, I'm going to go a little bit farther. I'm just going to list factors. So I've got 1, 3, 2, 5, 6, 10. Are those all factors of 30?
Yes.
Yeah.
I mean, yes.
They are all factors of 30, but they're not factor pairs, so that works, doesn't it? They are not an example.
Yes.
Okay? Anything additional? Anything else we can throw up there?
No.
Do factor pairs have to be prime?
No.
No.
But
Can be prime or composite. That way we know that we're not talking they absolutely have to be prime numbers. Okay? That way there's no confusion. Do you agree?
yes.
I think that's all that we're gonna go with there, okay? Where does the vocabulary, go when they're
Underneath the tab
completed?
that says vocabulary.
Behind the tab that says vocabulary,
Behind the first one.
okay?
I was
Okay, we're gonna do one. Guess what? You're not gonna have an assignment today, but we're gonna move on. This says, list the factor pairs of the number. Okay? We got the number 18. Factor pairs. That's all we gotta do is list the factor pairs. Well, I know this one is. Oh, and if I'm listing the pairs, I have 1 and 18. Do you agree with that? Are those factor pairs? Yes, they are. What other factor pairs can you come up with for the number 18? And you know what I do when I go to looking for those? I just start going, because sometimes when you list factor pairs, you forget one or two. But if you go down the rules of divisibility, you're not going to forget anything. Okay? Yes, sir.
Will we do sevens now and fours?
We may, yes.
Okay.
Okay? So, is the number 2 part of a factor pair for 18?
Yes.
Isaiah 2 and what?
9.
Good. Are there any other factor pairs for the number 18? Gabe,
6 and 3. 3 and 6.
I'm going to go with 3 and 6, okay, Gabe? Just because I like to keep that order. I'm just kind of funny that way.
But like we can fun.
Yeah, that's kind of what I'm doing. Are there any other factor pairs for the number 18? Brianna? Brianna.
6 and 3.
But I already listed it here.
9 and 2.
But I already listed it.
And there's none.
Okay, so you see what I'm saying? On the factor pairs, and that was inappropriate, I didn't like that look, okay? I'm just telling you. On factor pairs, it's not like the example with the band teacher. On that example, we wanted to know all the different arrangements. On factor pairs, if you've listed the 2 and 9, you don't relist the 9 and 2 because that pair is still the same as the pair you already listed. Does that make sense, Brianna? Okay, does everybody else get that? We only list that pair one time. The order of the pair really doesn't matter. Okay? I just prefer, personally, I like it this way. But if somebody listed the others as 1 and 18, 9 and 2, 6 and 3, would they be wrong? No, they would not be wrong. They've got them all there. What about the number 24? Give me a factor pair for the number 24. Maddie?
4 and 6.
Maddie says 4 and 6. I totally agree. Give me another factor pair for the number 24. Callie? 3 and 8. I agree. What's another factor pair, Caleb? 12 and 2. What about another factor pair? Is there any more? Kinsey?
1 and 20.
1 and 24. Anything else, or do we have all of them?
We have all of them.
I think we have them all. Now, I'm going to go back. 1, 2, 3, 4, not divisible by 5. 6, not divisible by 7. 8, not divisible by 9 and 10. Do I have them all?
Yes.
Huh. What did I just do? I just did my rules of divisibility to double check. Okay. 51. Woo-hoo. 51. Is it going to trip you, or are you going to trip it? Okay, Isaiah.
5 times 1.
Pardon?
51 times 1.
1 and 51. I agree with that. Are there any other factor pairs for the number 51?
Yes. Yes, there is.
Is there, Kagan?
Wait. Yes.
What?
3 times 17.
Yep, that's right.
You are absolutely correct. And how do you know that, Kagan? Cause I know you don't know your 17s.
Because I counted from up to 51 to 60 because I know 3 times 60 and 1 is 60.
No, that would work. That would be one way. Amelia?
Because 5 plus 1 is 6, so 3 can go into it. 51 divided by 3 is 17.
Right there. Rules of divisibility tells me. I added 5 and 1 and I got 6. And the 6 is divisible by 3. So I had to have a 3, a pair with a 3 in it. Is it going to be divisible by 4?
No.
Is it going to be divisible by 5?
No.
6?
No.
7?
No.
8?
No.
9?
No.
10?
No.
Do I have all the factor pairs?
Yes.
Yes. These are lists of factor pairs. These are lists. And if you're asked to list, this is what you're going to be doing because it's list. Okay? You do not have an assignment tonight because we've got some more stuff we're going to do before I give you the assignment.